Hi, this is Jack Buffington for Hackaday.com. This week we pick up where we left off last week and continue making a custom part in Eagle CAD's library editor. Then we finish up the schematic that we started last week. So here we go with part 2 of how to create your own circuit board in Eagle CAD. Right here where I have my mouse is where you can create a surface mount pad. I'm going to click on that, and now I am dragging around a pad, but it's not the right size. So here I'm going to type in the new size. They recommend 0.55 by 1.5 millimeters. I'm going to make mine 0.55 by 2.5 millimeters. And I should also say, we first need to go up to View, Grid, and we have to verify what units we're using. So right now, the units are 0.5 by default, 0.05 inches. I'm going to change that to 0.8 millimeters. And then I'm going to change this one to finest. And I'm going to click OK. Now my units for the pad sizes show up in metric instead of imperial units. So I'm going to type in 0.55 by 2.5. And I get this big long pad here. The TQFP44 has 11 pads per side. So now I'm going to create 11 pads. And since I set my spacing to the spacing that is needed for the package, I can just go ahead and click on every grid point here. So 1, 2, 3, 6, 7, 8, 9, 10. So now I have the 11 pads for one side. The datasheet says that the center spacing between the pads on the opposite sides of the TQFP package is 11.4 millimeters. Because I've extended the pads, my pads, an extra millimeter, I'm going to make the spacing 13.4 millimeters so that we get an extra millimeter sticking out of either side. So half of 13.4 is 6.7 millimeters. So I've gone into the grid units here and I've changed the spacing to 6.7. Now I could either use this, or I can type group, or even like probably GRO would probably work. I highlight the parts I want to move. Now I use the move tool, which is right here, or I can type MOVE, or MOV works as well. And I right click in the editor window and up comes Move Group. Now I can move the group. So it's that simple. Now I'm going to go back into Grid and change this back to 0.8. And create some more pads. You'll notice that I'm rotating the pads. The way that you can rotate pads is by right-clicking. Group these, change my spacing. I could also do it like this. I'm hitting the Alt key to get the secondary spacing. That allows me to space these properly here. Okay, now I have the pads all drawn for this part. Now it's time to indicate where the part might be sticking out of. In my case, D1 and E1 on the part sheet are 10 millimeters. So I'm going to change this to 1 millimeter. Actually, we'll change it to 0.5. And by looking right up here, I can see where in the grid I'm located currently. So I'm going to go to -0.5. It actually looks like my package doesn't stick out very far. Oops. Here's another thing now. I've gone into the line tool, or the trace tool. Here is what layer I'm currently working with. So I've got top and bottom. I want to use T-place. If we look up here at this box, we're currently drawing in the top layer, which is the top copper layer. What I need to do is go to the T-place layer, which is your top silk screen layer, and now I can go ahead and draw the silk screen. Now you'll notice that by default it's drawing a line with a square corner in it. By right clicking I can change how it draws that. So now it's any which way. Here it's an angle first, then a straight line. Here it's straight line vertically first, then horizontal line. I can do curves. There's curve the other way, and back to, I think this one allows us to, yeah, have continuous curves like that. In any case, I'm going to go just like that. In this corner, I want to indicate that it is where pin 1 is located. And I just hit escape to complete the project. You can put a corner into a line by using this tool right here. This allows you to add corners into a line. So I had previously made this corner diagonal, but I wanted to add a corner, and so that's how I did it. It's this corner that I want to make be pin 1, and I've changed my mind on how I'm going to indicate that. I'm going to just put a circle instead. Typically when I'm drawing, I like to set my grid so that the alternate is set at finest. This allows me to position things as I want. By just holding down the Alt key, I can position this in a place that's more desirable than one of the grid spots. So now we have the top silk screen, the pads. If I go here, this is my layers. I can turn on and off which layers I'm seeing. So TStop, if I turn that on, you can see right here, this prevents the solder resist from being over top of the pads. If you're designing your own custom pads, you would need to put TStop in there. Otherwise, when you get your circuit board back, you won't be able to solder onto your pads. I'll just turn that back off because it's annoying. Alright, the final thing that we need to do is we need to name the pins. And this is sort of a tedious process. You just have to go through, and it's just something you have to do. While I'm doing this, I'm just naming them by pin number. We'll get to addressing what these pins actually do in the actual schematic part, because we may choose to use this TQFP 44 pin device for some other part in the future. Now we have the package all done. let's save it and switch over to our schematic. And I'm going to create a new one. This is going to be a PIC 18F44J11. So we've created a new schematic part for that. There's just no good way to really lay out something like this, so we'll just start here. This is an I/O pin that I've created here. You can set various attributes of the I/O pin. The first is orientation, but that you can just do by right-clicking, so it's not really that important to do. You can also set how it displays. I don't generally do that. I do often shorten it to this because a lot of the parts that I work with tend to have high pin counts. And finally, I like to set it on this one. You can have it so that there's no labels on the pin, a pin number, or a pin description, or both. I tend to like to have just a pin description. So the circle part here of the pin is where you will actually connect to. For the PIC 18F44J11, I have 5 ports, ports A through E. And I'm going to create those now. So this is port A. Port A does not have a pin 4 that I'm finding on a quick look of the data sheet. I may need to fix that at some point, but right now I'm not seeing it. Port B is a full 8-bit port. So we'll just add 8 pins. And I need to move that pin. I clicked in the wrong place, and the move tool or type MOV, MOVE works up here just as fine. Keep adding pins. Port C is an 8-bit port. My scroll wheel allows me to zoom in and out, and it zooms in and out of the place that my cursor currently is. So that can be a pretty handy thing. If I want to center pin 15, I can zoom way in and zoom out like that. A, B, C. Port D is a full 8-bit port. 8. And port E has 3 pins. You can lay these out however you would choose. I'm sticking them all on one side. Now I'm going to draw the shape for the processor. Just draw it kind of big like that. You don't really have to do this, but it helps keep track of what is what in your schematic. Now I can go in and I can label my pins. So if I click on the pin, I can say that this is A0, A1, and so on and so on. This chip has 2 positive connections and 2 negative connections. And so what I'm going to do is add some pins up here and 2 pins down here. And I'm going to label these ground 1. I tend to stick these on the bottom. The ground's on the bottom of the part and the voltage in on the top of the part. You can't have 2 pins labeled the same for whatever reason in Eagle CAD. I think that has something to do with you can script things in Eagle CAD. I haven't used that functionality, but I believe that may be why. And here I have power pins. Finally, I have a pin that a lot of PICs don't have, and this is where you can connect a capacitor to ground to help stabilize the core power. It's something kind of new for me. We're only adding only one extra pin up here, and that is the memory clear pin, which is used in in-circuit serial programming and as well to reset the device using a button or something like that. The other pins that you use to do in-circuit serial programming are actually on port B. So they are on port B 6 and 7. So I'll relabel this one. Alright, between that cut and now I have labeled all of the pins. Now we're going to go into our device editor. We're going to create a new device. I'm going to call this PIC 18F44J11. Okay. I'm going to add a part or a symbol, and this is the symbol I just created. Shows it to you here on this window, and I'm going to do a new package, and I only have one package in my library at the moment, and that's the TQFP44. So we're going to add that. Now something to note is that you may want to label what this variant is called by renaming it. I can right click on here and go rename, and by default it has a quote in there, but I'm going to call it TQFP-44. And the reason I'm doing that is not so much for this project, but if I were to ever use this processor again in a different package, such as the leadless package, I could change my design very easily by just importing the package into here and you can part swap. So I wouldn't really need to, if I was trying to shrink down my board and I wanted to use the leadless package because it's a little bit smaller, I could just swap parts instead of totally rewiring the whole board again using a different part altogether. So now I will click on the TQFP44 package, and you can see it has a little exclamation point here. I'm going to click Connect, and I am presented with a list of the names. Now it always puts this $G thing here, but we have the names that we added later here. And here are the names that we named the pads. In this case, I have just named them 1 to 44. So to connect, let's start with pin 1 on this package is C7. So the pad is 1 and this is C7, and I can click connect down here and it shows up into this list as well, showing that C7 is connected to pad 1. Pad 2 is D4. Click connect, and here's the long boring process again that we're going to skip over, or maybe watch me do it in high speed, and I'll get back to you after that. In our data sheet, you can see that pin 12 and pin 13 are labeled NC, which means no connection. All I'm going to do here is I'm going to skip over them and just go to pin 14, which is B4. So there we go. I have all of the pins connected now, except for the pins that have no connection. I'm going to click OK, and I'm going to click Save. Now I'm going to close out my library editor and go back to my schematic. Now back in our schematic editor, I'm going to add the part that I just created. So here is our library. Open it up. There's only one thing in it right now. I'm going to say OK. And since this is such a huge part, I'm going to zoom out a little bit and stick it off to the side. So now we have 1, 2, 3, 4, 5, 6 parts in here. What I need to do is do a little bit of connecting up of things. So I'm going to take my crystal and I'm going to type move, and I dropped this crystal attached to these two capacitors because that's how it's going to be in the final thing. I'm going to move that over here. They're now attached. And I'm going to run a wire by typing wire, or by clicking over on this button right here. I prefer to type things. I'm going to connect up there and hit escape so it stops that connection, and connect to here and hit escape. Now I'm going to move some things around. I can rotate my parts again by right clicking, and let's stick the LED on V0, and the capacitor's going to go over here. One final thing before I just take you away from this section of it is that you need power. And I am going to add, if I go into the supply section, supply 1, we'll just say plus 3.3 volts. And I'm going to put a capacitor there because this is our decoupling capacitor. There. And I'll hit escape, and I'm going to select ground, and I'm going to connect ground there and there, and we actually need another one over here, one here. Now I need a capacitor to go between VDD core and ground, but I neglected to put one there. Now I could do add, which would allow me to go in there and I go find that capacitor again, or I can type copy. And now I click on, this capacitor here and put it over there. I could connect a wire by clicking on a wire and running it from here to here, but I can also do move and drag my ground over there and back, and now it's connected. So there you go. That's and actually I'm going to copy my ground one more time because I need that for these capacitors here connected to the crystal, and I need it for this LED. I may have this miswired with the LED. I can't recall if that is a 3-volt LED or if I need a resistor in there as well. I'm going to leave off there now. Next week we'll get to how to place your parts on the PCB and route the traces between them. For Hackaday.com, this is Jack Buffington, signing out.